আসসালামু আলাইকুম। আজকে আমরা ক্লাস শুরু করতে যাচ্ছি। গত ক্লাসে আমাদের আলোচনা হয়েছিল বিভিন্ন রকম কনস্ট্রাকশন সম্পর্কে এবং আমাদের মেইন টপিক ছিল সিনক্রোস। তো আজকে আমরা রিজলভার সম্পর্কে পড়াশোনা করব। although সিনক্রোস এন্ড রিজলভার আর দ্য সেম, অলমোস্ট দ্য সেম, কিন্তু তারপরেও পার্থক্য আছে কিছু সিনক্রো এবং রিজলভারের মধ্যে। তো আমরা সেগুলো গ্র্যাজুয়ালি দেখবো যে কিভাবে সিনক্রো এবং রিজলভারগুলো থেকে আমরা এঙ্গুলার পজিশন মেজার করতে পারি, সেগুলো আজকে ক্লাসে আমরা দেখব। তো সিনক্রোতে যে বেসিক্যালি যেটা ছিল সেটা হলো যে অ্যাঙ্গুলার পজিশন ডিটেক্ট হবে সিনক্রো দিয়ে, এবং সেখানে আমরা দেখেছিলাম যে আমাদের 3টা উইন্ডিং দেওয়া ছিল। তো 3টা উইন্ডিং এর মাধ্যমে কিভাবে অ্যাঙ্গুলার পজিশন ডিটেক্ট করা আমরা জেনেছি। আজকে আমরা দেখবো যে রিজলভার দিয়ে সেই একই কাজটা কিভাবে করা যায় সেটা আমরা দেখবো। তো ফার্স্ট হচ্ছে হোয়াট ইজ এ রিজলভার। So basically the first question is that what is a resolver? So a resolver is basically a rotating device or a rotating machine which can detect the angular position, is known as resolver. So in this point there is no significant difference between a synchronous and a resolver, because the definition is almost the same for synchronous and resolver. সিনক্রোস বলার সময় আমরা বলেছিলাম যে এটা অ্যাঙ্গুলার পজিশন মেজার করতে পারে, রিজলভার করার সময় তাই বলছি যে এটা অ্যাঙ্গুলার পজিশন মেজার করতে পারে। সুতরাং এদের যে ফাংশন অথবা পারপাস এটা একই। The function or purpose is the same. The function বা পারপাসটা কি আছে, এই ফাংশন বা পারপাসটা আসলে সেম। পার্থক্যটা হচ্ছে যে এদের কনস্ট্রাকশনে construction and working principle according to the construction or working principle they are different. কি হলো যে একই সাথে একটা সিনক্রো এবং রিজলভারটা সেম আবার সেম না। So according to the definition, so it is same, and according to the construction or working principle it's different. So let's discuss about the construction. So this is the cutaway view. So this view indicates here the each and every layers of the resolvers. The model number is located here. So this is a practical used resolver and very commonly used resolver. So how does it look like? It looks like just a potentiometer or a variable resistor we have used in our laboratory. So you know very well your the construction of your potentiometer, and it's just a bit bigger size than that of the potentiometer. The size of the resolver is just a slightly bigger size than that of the potentiometer in your lab, and there is a shaft actually. So the shaft is mounted to the rotor actually. So the rotor is inside the resolver as located here. So if we cut down the stator part, so it will explore the inside structures such as the rotor and shaft and the other components. So this is the shaft actually, and this is the same thing, the shaft is also shaft, and this is the rotor windings. So there is basically only one winding, just like this. So basically the rotor consists a winding, and the stator windings, there are two stator windings, which is not clearly seen from this figure. We will describe the stators later, but the stator windings are two actually. So there are basically two stator windings and a rotor winding. So this is the construction, and there is a coupling, and this is stator and rotor leads. This is the leads of the stator and rotor. And although it is located, this is input shaft, but the shaft is not always the input. Sometimes the shaft could be used to take mechanical power, or sometimes it could be used to deliver mechanical power. It depends on whether it will function as a receiver or transmitter or other purpose. If the resolver functions as a transmitter, in that case the shaft receives the input mechanical power from the radar antenna or any type of weather forecasting device or so on. So it's just like an indicator. It's just like an indicator, and it's mounted to the shaft of the transmitter. So it depends on whether the resolver is functions like a transmitter or receiver. So in general case, the resolver functions as a transmitter, therefore it can be written that the input shaft it takes the mechanical power from the rotating object. Otherwise, it could be a receiver. It could receive some mechanical power, or it could deliver some mechanical power. So if it is situated in the receiver side, the same shaft could be mounted to the dial. So this is a dial, and it could be mounted to the dial. The shaft could be mounted to the dial. So this is the internal structure. According to the description I have just described, according to this description, there is actually this is the cross-sectional view of this resolver, which we have just described. So in this figure, the vertical and horizontal windings are very clearly seen. So one is the vertical winding, another is the horizontal winding, and why the name is so, we'll describe it later. And there should be a rotary transformer. The rotary transformer is just like a transformer where the primary is free to rotate, and the secondary is there is the voltage is induced in the secondary. And you know that the variac is just like a rotary transformer. So you have used variac in your laboratory to vary the DC voltage, and the rotary transformer is just similar to that device. And this is the shaft actually, and it is connected to the rotor inside, and the rotor is just laminated just like this, and there is a squeezing. So there is some inclination actually. The inclination is just to support the lamination, and because of this, the iron loss would be low actually, and it can deliver or receive the rotational or mechanical power well. That is, it is related to the torque tube, as you know, and there is a lamination core. This core is laminated, and there is some skewing actually in the rotor structure. It looks just like a small motor. It looks like just like a small motor. So this is the internal construction, and what is inside this? So one is the vertical winding, which is known as cosine winding, and the other is the sine winding. Sine winding is located here. So this is sine winding is written here, and this is cosine winding. So in the stator part, there is basically two windings, as we have seen in the right hand side, the figure situated on the right hand margin. and there is only a winding in the rotor. The rotor, we can represent the rotor by just place a rotor here. So this is the rotor actually. Rotary transformer. So rotary transformer. A rotary transformer, and if we do not consider this rotary transformer here, we can simply supply the AC voltage to the rotor. The sinusoidal voltage we can supply it to the rotor. So this is the thing actually. So this is the input, and if the rotor rotates as it is mounted, this is the center of rotation of the rotor, and it is mounted to the antenna, or it is mounted to the weather forecasting indicators or whatever. It is mounted to the antenna and it is mounted to this. So the later construction, and the stators are situated, and it is stationary. There are two stator windings, one is the sinus winding, and this is stationary actually, and there is an induced voltage in the terminal. The cosine voltage is denoted as Vc. Vc denotes as the voltage induced in the cosine winding, and Vs indicates the voltage induced in the sine winding. So this is the basically the construction of the resolver actually. Now we have to discuss the working principle. That is, what is the working principle of this? So we have to share a new slide, and before going to the new slide, we have to erase this thing. So if you have any question regarding the construction, you can ask me. Then I am going to describe its working principle later. So is it very clear to you? Then I can proceed to the next slide. তোমাদের যদি কারো কোনো বুঝতে অসুবিধা থাকে এই সিঙ্ক্রোসের কনস্ট্রাকশন সম্পর্কে, তাহলে আমাকে জিজ্ঞেস করতে পারো। আর যদি এটা সম্পর্কে ক্লিয়ার আইডিয়া থেকে থাকে, তাহলে আমরা হচ্ছে পরবর্তীতে এটা কিভাবে ফাংশন করে ওয়ার্কিং প্রিন্সিপাল থেকে আস্তে আস্তে মুভ করব। And when it says there is no question, so therefore I can assume that all the things are very clear and that it is so easy to understand. So, and I'm going to the next description. Is we have to describe the function of a reservoir and how does it work actually. So now we are discussing the working principle. The construction part is over and we're discussing working principle. So what is the working principle actually? So if it is rotor, often the rotor is a circular shape is used to represent a rotor, and here it is. We have found the circular shape which represents the rotor. Wait a bit. Actually, there is a winding in the rotor which is located outside the rotor. This winding is the rotor part. and this is the supply voltage Vs, and the supply voltage is connected to the terminals of the rotor, and the supply voltage must be AC as indicated here. So this is the input voltage. So this is the electrical input. So the rotor receives two-way input. It receives electrical input, and in the same time it receives input. So two inputs are received by the rotor simultaneously. The mechanical input comes from the radar antenna. Or it could be this is from the weather forecasting office, like airflow indicator, and so on. The mechanical input, it receives from any type of antenna or indicator, and the electrical input, it is supplied by Vs. So we have to remember that the rotor of a reservoir receives two types of input simultaneously. It receives electrical input, and at the same time it receives mechanical input. Then for the electrical input, it produces a voltage across it, and if the rotor is not rotating, if the rotor is just like this, that is stationary position, if the rotor is in stationary position, therefore the rotor could be aligned with this one, and this is the horizontal winding, and the other is vertical winding. The horizontal winding is represented as V cos theta, and we could use Vc sine here, and the sine winding we can use the voltage across the, which is represented as phi2, we can represent it like Vs. So this is the input voltage V in, and because of the application of this V in, the voltage is obtained across these two terminals, that is phi1 and this is phi2. Only the condition is that if there is rate of change of flux in the rotor, that is ddt of phi is there, only in that case there would be an induced voltage in the phi1 and phi2. You have to remember, until there is no rate of change in the flux here, we will not get any type of variation in the phi1 and phi2. So this is the working system. Then how to calculate the voltages? So there could be three cases. So there should be three cases for which we can denote. This is case 1. If it is case 1, so case 1 where theta is equal to 0 degree. Three cases should be there. One is case 1, theta is equal to 0 degree, and the other is case 2, theta is equal to 90 degree, and the other is case 3, theta is in between 0 degree to 90 degree. Theta is in between 0 degree and 90 degree. So this is case 1, this is case 2, and this is case 3. So let's discuss about case 1. So what would be there for case 1? If theta is equal to 0 degree, it means that if we consider this is x-axis and this is y-axis, if the coil is just along x-axis, if the coil is just along x-axis for now, so the theta will be 0 for this position. For this position, theta will be 0, and the voltage across the vertical and horizontal winding is like this, then VC and VS. So this is horizontal winding or cosine winding. So this is V cos 0. So V cos 0 degree means is equal to, that is V into 1, that is it is V actually. So we can control like this actually nothing, no other than value without V. So V should be Vm, the V max. While the voltage of Vs is equal to Vm and sine 0, and as we know the sine 0 equal to 0, so we'll get 0 voltage. Vm into 0 means 0 volt. So this is for case 1. So undoubtedly if theta is equal to 0 degree, there will be no voltage component for the sine winding or the horizontal winding. Only there should be the voltage component in the vertical winding. Fully voltage would be induced in the vertical winding. And the coupling coefficient also Cc is the maximum for this position. Now let's discuss for the second case. Case 2, theta is equal to 90 degree. If theta is equal to 90 degree, and if we put the value here just like this, so Vc is equal to Vm and cos 90 degree, and again Vs is equal to Vm sine 90 degree. So we know the sine 90 degree is equal to 1, so it results Vm again. And we know that cos 90 degree is equal to 0. That is why Vc is equal to 0 for this position. And for this case, the coupling coefficient is the maximum for this position too. And in that case, there is theta actually. There is a right angle. It means that the coil is now aligned like this. So if you align the coil with the previous winding, so if the coils are now placed in this direction, the coil is now that is fully aligned with this phi 2. So this one, if it is phi, and phi 2 is totally aligned right now. Phi and phi 2 are totally aligned for this position. Before doing that, the phi and phi 1 was the aligned position in the previous cases, but now phi and phi 2 are the aligned position in the present situation. So this is the thing actually. So this is case 1 and this is case 2 and this is case 3, 0 theta 90 degree. So if the position of rotor is other than 0 or 90 degree, that is if the position is in between 0 to 90 degree, for an example if theta is equal to 30 degree, so what will we get actually? So if we place the coil 30 degree along with this, what will we get actually? So what would be the voltage? So now the coil aligns with like this. If the coil aligns 30 degree, so what will be the induced voltage in the Vc and Vs? So let's discuss about this thing. Vc is equal to Vm cos 30 degree, and again Vs is equal to Vm sine 30 degree. So what will we get actually? We get sine 30 is equal to half. We'll get Vm divided by root 2. Sorry, Vm divided by 2. And for cos 30 degree, you know that sorry, perhaps there was an interruption few seconds ago. No, it seems okay. The voltage, the theta is now 30 degree, for which the value of Vc is equal to root over 3 Vm by 2. root over 3 Vm by 2. So, and this is Vm by 2. So this is root over 3 Vm by 2. So now the voltages are different than that of the case 1 and case 2. And for case 3, the voltage induces both the windings, that is, it induces the vertical winding and at the same time it also induces the horizontal winding. But it partially induces this voltage and this partially induces this voltage. So if theta is other than 30 degree, it could be 60 degree or 45 degree or whatever. So there could be 3 cases. For case 1 and case 2, only one winding will be energized actually, and the other winding will get the minimum voltage, or it's totally unaligned. For case 2, phi 2 is fully aligned. For case 1, phi 1 is fully aligned, and for case 3, both phi 1 and phi 2 are partially aligned. None of them is fully aligned or not aligned, but all of them are now partially aligned. So this is the difference of case 1, case 2, and case 3. So this is the voltage we will receive from the terminals. So is it clear to you? So we can proceed. So if you have any question, you can ask me. এই পর্যন্ত যে ডিসকাশন হয়েছে তাতে যদি কারো কোনো সমস্যা থাকে আগে বলো, তারপর আমরা সামনের দিকে আগে যেতে পারি।
না স্যার, কোনো কোশ্চেন নেই।
ঠিক আছে, থ্যাংক ইউ। It seems that it's too much easy actually. It's nothing, there is nothing complex, just like other topics. আমরা এখানে এখন এটাকে একটু ক্লিয়ার করে দিয়ে সামনে একটু আগাতে পারি, তাহলে এই জিনিসগুলো একটু কমাই দিই। এখন কথা হলো যে এখানে রিসিভার এবং ট্রান্সমিটার হিসেবে যখন কাজ করবে, তারা এখান থেকে কিভাবে আমরা রিসিভার এবং ট্রান্সমিটার হিসেবে কাজ করবো সেটা একটু বলে নিই। আচ্ছা, তাহলে আমাদের জন্য ভালো হবে। প্রথম কথা হলো যে এখানে যে ভোল্টেজটা আছে ভিসি এবং ভিএস, এই ভোল্টেজটা থেকে আমরা কিভাবে মানে রিসিভ করবো অ্যাকচুয়ালি সেটা আমরা বলে নিই। So there will be 2 cases. One is if it is work as a transmitter, so therefore we can write this is a rotor and this is Tx. If it functions as a transmitter, then what would be voltage of the receiver side? So there will be a voltage which should be transmitted from the transmitter to receiver like this. So and the other voltages should be transmitted like this. So there would be 4 wire. If you want to transmit the voltage from primary to receiver, we will require 4 terminals. And the rotor part, there is another 2 terminal which is common for both the transmitter and receiver. Therefore we need a 1, 2, 3, 4 and 5, 6. We need 6 wire for this configuration. On the other hand, if we want to receive the voltage from other side, and if the voltage is received from the transmitter, so what will happen? And there is a way actually you can use also a common terminal for these 2. We can also use a common terminal, or we could use different terminal as we have discussed. So this is for the transmitter side, and if it is works like a receiver side, so what will we get actually? So for receiver side, the value will be different. If it works like a receiver, so the transmitter should be replaced with receiver sign. Now that is Rx, and similarly there should be a rotor side voltage, and these voltages are from stator side. The stator side, this is for one winding and this is for another winding. So if there are 2 windings mainly, so it requires 4 wire, and the rotor side requires 2 wire. So 2 wire plus 4 equal to 6 wire is required, or we can minimize 4 wire into 3 wire. then total fibers will be required. So we can simplify the fact that both the same resolver can work as a transmitter or a receiver. So just like the synchro, if a system is made with synchro, both the transmitter side TX and the RX side receiver, so there could be three cases. First cases, TX should be synchro and the receiver should be synchro. Then TX should be resolver and RX should be resolver. So this is case 1, this is case 2, or we can use case A, case B as they are different than the other cases. And we are discussing now case B. We are studying now resolver. So now this part is completed. So if the voltage comes from the other resolver, similarly it will produce the same rotation in the rotor side. For now, the rotor will act as a dial or indicator rather than the antenna side. So two resolvers are required to complete a whole system of TX and RX, or we need to use two synchros to make a complete system. And in case C is the special case where we can use a transmitter with a synchro and the receiver is a resolver. This is pretty much interesting than the other two topics. তো এখানে যেটা হচ্ছে যে দুটো সিঙ্ক্রো দিয়ে একটা সিস্টেম তৈরি হতে পারে, দুটো রিজলভার দিয়ে একটা সিস্টেম তৈরি হতে পারে, আর একই সিস্টেম একটা সিঙ্ক্রো এবং একটা রিজলভার দিয়ে তৈরি হতে পারে। তো আমরা এখন দেখবো, এর আগে আমরা দেখেছিলাম আগের ক্লাসে যে দুটো সিঙ্ক্রো দিয়ে কিভাবে সিস্টেমটা তৈরি হয়। এই ক্লাসে আমরা দেখলাম দুটো রিজলভার দিয়ে কিভাবে সিস্টেম তৈরি হয়। এই ক্লাসে আমরা দেখবো যে কিভাবে একটা সিঙ্ক্রো এবং একটা রিজলভার দিয়ে আমাদের সিস্টেমটা তৈরি হয়। সো লেটস হ্যাভ এ লুক এট ইট। আমরা এখানে দেখবো যে একটা সিঙ্ক্রো এবং একটা রিজলভার দিয়ে কিভাবে তৈরি করতে। তাহলে আমরা এটা একটু ক্লিয়ার করে দিই, ক্লিয়ার করে আমরা নেক্সট টপিকে চলে যাই। একটা সিঙ্ক্রো এবং একটা রিজলভার থাকবে আমাদের। সো হাউ ক্যান উই ম্যানেজ ইট? So this is the way actually. এখানে আমরা দেখতে পাচ্ছি যে have you see that this is the transmitter side of TX and this is the receiver side of RX, and this receiver side RX there is a resolver actually other than a synchro, and the TX side consists the synchro. So this is a hybrid system actually where the transmitter is composed of a synchro whereas the receiver is composed of that of a resolver. So how can we connect the resolver with the synchro? The topic explains this thing explicitly. So before doing that, we have to remember the Scottic transmitter transformer. Sorry, both of you know all of you know the Scottic transformer connection. It is studied in your second year. While you studied in second year, you know the Scottic transformer very well. So there is nothing special. It's just like a T configuration. And what we have to do actually, if you want to convert a resolver into a receiver, so at first we have to make some tapping. So hopefully you know the center tap transformer. So there are two types of center tap. One is, suppose if it is primary side, we have to consider two transformers. One transformer is like this, the other transformer looks like this. So we have to take two transformers, but only the difference is that we have to make a center tap in the first transformer. So what is center tap? Suppose there are total 200 windings. If there is total 200 windings, so we have to make a center tap by dividing the 200 windings into 100 windings in both sides. So if you split the total turn number into two equally, then the turn number will be 100 and 100, and this is the center tap or CT. And the other side, the voltage is like this. This is 86.6%. 86.6%. So all of these are tappings. Okay, only the difference is that we can make a tap anywhere from the starting up to the end terminal. The tapping could be 90%, 80%, 70%, or so on. If the tapping is in the middle position, in that case, we call the tapping as center tapped. So we have to use two different transformer. One is center tap, and the other should be tapped at 86.6% of winding. Suppose if there is 200 turns of winding, then we have to split into 86.6 multiplied by 2. So what will it get actually? So it's all around 27 and half. So it is, let me calculate the value. 86.6 into 2, it means that 173. It's around 173 windings, 173 turn number here, 173 turn number here, and the remaining 27 turn should be there. This is, and so on. So we have, if the turn number n is 200, so we have to 200 turns. So we have to split 100 plus 100 turn for the first transformer. We have to make 100 plus 100 turn number for the first transformer, which is known as center tap transformer. For the other transformer, the turn number should be 173 plus 27. So it becomes 200 again. Okay. So if we split the transformer like this and connect the transformer as well, then we can form a Scotty transformer. So what we have to do, we have to connect S1 into the tapped part, and the other terminal of this transformer is connected to the center tap of the second transformer. Then the remaining part would be the S3 and S1, S3 and S2. So we have now connected S1, S2, and S3. Following this connection, which would reproduce exactly the same voltage of the vertical winding and in the horizontal winding as well. So VC, sorry. So this is VC and this is VS. So this is the horizontal winding, this is the vertical winding, and this is the horizontal winding, as this is sine theta. This is sine winding. So this is VM sine theta. This is VC equal to VM cos theta. So if we make a rotation in the transmitter side theta, the same theta would be reproduced in this side following the case 3 condition. This is case 3 condition, sorry, case 3, not case C condition. So this is case C condition. So this is the thing actually. This is the way how to connect the Scotty transformer with the synchro and resolver, so that we can reproduce the same angular position for angular position detection and measurement. So if it is clear to you, you can ask me. এটা যদি ক্লিয়ার হয়ে থাকে আমাকে বলো, তাহলে আমি পরবর্তী পাঠ শুরু করতে পারি। এটা কি ক্লিয়ার হয়েছে তোমাদের কাছে?
জি স্যার।
হ্যালো, আচ্ছা ঠিক আছে। এবং এটা আই থিংক ইটস ভেরি ইজি টু আন্ডারস্ট্যান্ড অ্যাকচুয়ালি। এটা খুবই সহজ বোঝার জন্য। আমি এরপরে বাকি অংশে চলে আসি, যে সিনক্রো রিজলভারের যে তুলনামূলক পার্থক্যগুলো এবং এদের যে অ্যাপ্লিকেশনগুলো সেগুলো আমরা একটু দেখে নিই। যে রিজলভারের যে এতক্ষণ পড়াশোনা করলাম, এই রিজলভারের সুবিধাগুলো কি কি, এখানে সুবিধাগুলোর মধ্যে একটা লেখা আছে যে it can it can measure absolute or accurate position. So this is one of the advantages. তো আসলে এটার দ্বারা কি হবে, এটার দ্বারা আমাদের অটোমেট যে প্রিসিশনের যে জায়গাটা, প্রিসিশন ভাবে এটা পজিশনটা সেন্স করা যায়, এটা একটা সুবিধা। আর এর সাইজটা কি স্মল সাইজ কি কারণে আমি তো সেটা বলেছি। স্মল সাইজ হচ্ছে এই কারণে যে রিজলভার কনসিস্ট টু উইন্ডিংস, ঠিক আছে, in the stators, whereas the synchros contains 3 windings. So one winding is less here. একটা উইন্ডিং এখানে আসলে নাই, তো এটার কারণে ওটা আসলে স্মল। That is very compact and lightweight, and this is well suited to severe industrial environment. So severe industrial environment means the harsh environmental issue like temperature or pressure or humidity, or there are some gases. So in this aspect it is actually it is well suited for this harsh environment, and no require of ohmic contact. As we have described in the working principle, we don't found any ohmic contact between the stator and rotors, and its reliability is totally high. Its reliability is quite high. So these are the advantages. And another thing is that what are the application actually. So if you consider about the application, the resolver can use in several places. The synchros and resolver both can use in naval weapons, so radar antennas. So radar antenna we have already discussed, that is. So how does it work actually? And the naval weapons we didn't discuss it, but in ship and different types of water vehicle it could be used, and aerospace it is used actually, and the robotics or industry or automation it is also used. So synchro and resolver can it is there is a widespread application. And what are the difference between the synchro and resolver actually, and which aspect the synchro is suitable and which aspect the resolver is suitable? If we consider the size and its weight and portability, resolver could be a good solution, whereas if we consider the robustness and the reliability and you can use the outdoor use, synchros are often that is preferred actually. The synchro, the construction is very robust and very strong of that is the synchro, whereas the resolver is a sophisticated and precise device, and it's basically a smaller version of the synchro, you can say like this, and it can measure the position very easily or precisely. And what are the limitation of both the synchro and resolver? There is commonly there is a problem of this synchro and resolver. The problem is that if we asked what are the common limitations of both the synchros and resolver, the common limitation is that none the synchro and none the resolver can produce the proportional output. It always follows the trigonometric function instead of following linear function. Suppose we know that if theta is equal to 30 degree, what we want to say actually, if theta is equal to 30 degree and theta is equal to 90 degree, so here the difference in angle is 3 times, okay, 3 times. Whereas the voltage, if we look at the voltages, so for 30 degree the voltage would be Vm by 2, and the voltage for 90 degree would be Vm. It represents the voltage is almost the double or 2 times. So there is a discrepancy is like this. If the theta is increased 3 times, the voltage increases 2 times. So this is a non-linearity actually, because it follows the trigonometric function instead of following the linear function. So this is one of the major disadvantages of both the synchro and resolver. Neither the synchro nor the resolver can produce a proportional voltage or the linear voltage compared to its rotation. So this problem could be solved by another device which is known as inductor sync. Inductor sync, by using inductor sync we can produce a linear variable of the linear function where it is difficult to achieve in visual meta synchro. But this inductor sync is not included in our syllabus. Just we have to keep an idea that inductor sync, this is advanced technology by which the angular position can be detected linearly other than the non-linear characteristic. So we have now reached at the end of the slide. So if you have any question, please ask me. Here কি কালেক্ট করেছো আজকের অ্যাটেন্ডেন্স?
জি স্যার।
Okay, so thank you for attending today's class. Hope to see you in the next class.
Thank you, sir. Assalamu alaikum, sir.
Assalam. Take care.
Assalamu alaikum.
Wa alaikum assalam.